So far, we've talked about solving equations using addition and subtraction. We've also talked about solving equations using multiplication and division. Those are inverse operations, operations that undo each other. Now what we're going to do is talk about solving linear equations that may require two or more transformation. Two things to keep in mind. Simplify one or both sides of the equation if needed. Remember the golden rule of algebra that says what you do to one side of an equation you must do to the other. And also that you need to use inverse operations to isolate the variable. That's the goal. So one example is 1/3 x plus 6 equals -8. First, we're going to isolate the x term, and I'll be a little bit more careful with the notation. That's 1/3 times x. So we want to isolate x, so let's target the plus 6. We're going to target that, and it's plus 6. The inverse is going to be minus 6, which leaves us with 1/3 x equals -14. We now want to get rid of that 1/3. It's being multiplied by x right here. We want to get rid of it by dividing by 1/3, but you know that dividing by something is the same thing as multiplying by the inverse. So if we multiply by 3 over 1 here, we also have to multiply by 3 over 1 right there because of the golden rule of algebra. We now know that the 3's cancel, leaving you with just x on this side. And over here you end up with -14 times 3, which is just going to be -42. Here's another equation for us to solve together. 7x minus 3x minus 8 equals 24. There's a few things you can do first, but let's get rid of that 8 first. Talking about this one, the opposite of this of subtraction, the inverse is going to be adding 8. So we end up with 7x minus 3x equals 32. We now have two like terms. These are like terms because they both have the same variable, x, raised to the same power, 1. So if you have 7 of them and you take away 3 of them, you're going to be left with 4 of them. So 4x equals 32. You want to do the inverse of multiplying by 4, so you're going to divide both sides by 4. The 4 cancels, leaving you with x equals 32 over 4, which is 16. We also could get the distributive property in on the fun by trying to solve 5x plus 3 times x plus 4 equals 28. Now remember PEMDAS, parentheses. Let's do the parentheses first. 5x stays where it is, and now you have 3 times x, which is 3x, and 3 times 4, which is 12, equals 28. Let's now get rid of the 12. We're adding 12. The opposite of the inverse operation is going to be subtraction, leaving us with 5x plus 3x equals 28 minus 12, which is 16. We have two like terms right here, 5x and 3x, because x is the same, the variable is the same in both, it's x, and it's being raised to the first power in both cases. So you have 5 of them and you're adding 3 of them, so you have 8x equals 16. You do the inverse operation of multiplying by 8, which is dividing by 8, leaving you with x equals 16 over 8, which is 2. Things could get a little bit more complicated if you add in some negative numbers. So for example, you could have 4x equals -3 times x minus 2. So 4x, sorry, minus, not equals. And that's going to equal 21. We're going to distribute first because we want to get rid of these parentheses. And now we're distributing a -3. So you're going to have 4x minus 3x, because that's -3 times x. And then you have -3 times -2, so that's going to be plus 6, because you're multiplying two negative numbers, equals 21. We now want to get rid of the 6, so we subtract 6 from both sides, leaving us with 4x minus 3x equals 15. That's 21 minus 6. We're going to have two like terms here, which will just equal 1x equals 15. So we are done. Things can get even more fun when you add in some more fractions, which I know you're really excited about, right? Let's say we want to solve 66 equals -6 over 5 times x plus 3. Now you might think you'd want to distribute here first, which you could do, but one thing you can do is actually get rid of that fraction by multiplying by its reciprocal. If you were to multiply this entire equation on the left and right by the reciprocal of -6/5, you'd be multiplying by 5 over -6. If you multiply on the right by that, you also need to multiply on the left. The reason this is helpful is when you multiply something by its reciprocal, everything cancels out, leaving you with 1. So the right-hand side of this equation ends up equaling just x plus 3. And over on the left, it looks like a big number, but it's not that big because, it's 5 times 66 over -6. And you might know that 66 is just 6 times 11. So what ends up canceling is the 6 and the 6. So you're left with a 5, an 11, and a negative sign, so that's -55 equals x plus 3. So after 1.5 steps, or 2 steps, you have a pretty straightforward equation where you just need to subtract 3, leaving you with -58 equals x, and you can always reverse and have the same expression. It's equivalent, x equals -58. So just remember, be careful, label everything you're doing, remember the golden rule of algebra, and have a lot of fun. I hope you found this video helpful.